special triangles. We are moving to starting to talk about more about a single triangle versus multiple triangles together. Why did we talk about multiple before and we're going to a single now? The reason why we led with multiple is because we needed to figure out how do we compare those two triangles and realize that their sides are proportional to be able to take two ratios to make them equal, cross multiply and solve, to looking at one triangle and seeing that the angles and sides have a special relationship which is proportional as well. And we'll dive more into that. But looking at the notes today, pretty much that's all this is, and then you're going to practice. So I know some of you missed, some of you were out, a couple of you came in late. This is the gist of it, and I'm going to try and get through this as quick as I can. Adding a diagonal, add a diagonal through the square to create two congruent triangles. So I create my diagonal. What are the measures of each of these angles? Well, we started off with a square, so these two angles are 90 degrees. The other angles inside end up being bisected, so these two angles here are 45. That means that these two angles down here are also 45 degrees because we cut an angle, a 90-degree angle in half. We bisected. So the type of triangle that we created, if we focus on one of them, here I focused on the upper one, we created an isosceles right triangle, to be specific. Isosceles meaning two sides are the same, the third different from the third. Label the legs of each of these triangles one unit. So we're going to go ahead and we're going to label them one unit. Sorry, stepping on something on the floor there, it feels like anyway. All right, could be just my shoe, who knows? And again, why are these desks moved so close to me? I feel like I cannot breathe. All the other ones get moved up forward, that's why. Sketch one of the triangles. So we're going to sketch one of these, and we're going to label its sides 1 and 1. We're going to label the leg, or excuse me, the right angle a right angle, and we're going to label these other angles 45 degrees, so the legs are 1. So if side length is 1, side length is 2, what's the hypotenuse? How do I determine that? Well, this is one of the reasons why we reviewed the Pythagorean theorem the other day. Leg squared plus leg squared equals hypotenuse squared. 1 squared is 1 plus 1 is 1 equals c squared, or 2 equals c squared. And if I take the square root of both sides, c is equal to the square root of 2. Which should be reasonable because the hypotenuse should be just a little bit longer than the legs, if my legs are whole numbers. All right? Now it wants us to go through and repeat the process. And I'm going through this quickly, so if you need to pause it, pause it. But now it wants us to label each of these sides 2 units. So draw my diagonal, if I can. I'll have to go this way. Label each of the sides 2, and find the hypotenuse. Make sure you label your other angles in there 45. Now notice I'm not going to redraw, again, I'm not going to draw a triangle like that. I'm just going to use half of this shape right here. Side 1 is 2, side 2 is 2. Find the hypotenuse. Okay, so 2 squared plus 2 squared equals c squared. Now I challenge you, pause for a second and see if you can find the correct answer for the value of c. And then come back and unpause it and meet me here. Oops. Mr. Wilson messed it up. Mr. Wilson, go back and fix it. Guy, it's you can tell it's after hours here. School's been over. C squared, c is equal to the square root of 8. Now, if you got here, great. This is not your answer though, because we need to simplify this. The square root of 8 simplifies to 4 squared times the square root of 2. 4 is a perfect square, or 2 square root of 2. Moving on, question 7 wants us to do the same thing, but it wants each side of my square 4 units. If I can get this just right here. So 4, 4, diagonal, 90 degree, 45, 45. Side 1 is 4, side 2 is 4, 4 squared plus 4 squared equals c squared. Again, when you get to this point, pause, call a timeout and see how you do. And then come back and I'm going to go through and work through the rest of this. Hopefully you came back and you got the square root of 32, so you can progressively see, pause, and you can progressively see how, you thought I paused for a second, see how we did this. The square root of 32 simplifies or factors to radical 16 times 2. Again, think perfect squares. This is why we spent all that time on simplifying radicals. So we get 4 square root of 2. Now go back, and what do you notice about, oops, I gotta put 4 square root of 2 here. What do you notice about the relationship between the legs and the hypotenuse here? In this first one, the hypotenuse has a coefficient of 1. So this would be 1 radical 2. Notice that the legs are 1, hypotenuse is 1 rad 2. The legs are 2, hypotenuse 2 rad 2. The legs are 4, hypotenuse 4 rad 2. So when we get to number 8, and it tells us, hey, draw a diagonal, use 5 to be our legs here, what is our hypotenuse going to be? Our hypotenuse, you should be saying, is 5 rad 2. Well, let's prove that. Legs and legs are 5, so 5 squared plus 5 squared equals c squared, or 25 plus 25 equals c squared, or 50 equals c squared, or c equals the square root of 50. Square root of 50. Well, okay, so simplify the radical. 25 times 2, 25 is a perfect square, 5 square roots of 2. Yes, this relationship always exists. If I know the legs are 5, the hypotenuse is always going to be the value of the leg times the square root of 2. It's always going to be that way. So therefore, since it is, the diagram shows relationships. X and the hypotenuse is x times the square root of 2. It's always going to be that way. So how does the diagram show the relationship of the 3 sides regardless of the size? Okay? The legs are always the same. And I know I'm doing this real fast, but you can listen to what I'm saying. The legs are the same. You can pause if you need to. Okay? The hypotenuse is always equal to the leg times rad 2. Okay? It's always that same way. So now if we look at this, knowing the relationships, again, I'm going to finish this up real quick. Knowing the relationships, what's going on? Well, gee, if this one leg angle is 45 and this angle is 90, this angle has to be 45. Why? Because all 3 have to add up to be 180. So 90 plus 45, 135, plus another 45, 180. All right, so what is x equal to? Everybody's going to go 6. Why? Give me some reasons why. Legs are equal. Now you might even go say legs are equal in a 45, 45, 90 triangle. Legs are always going to be equal. So there's that. Y equals 6 square root of 2. Okay, why? Why does the leg equal 6 square root of 2? Okay, because in a 45, 45, 90 triangle, the hypotenuse is always equal to a leg times the square root of 2. That is a little formula I created up over here on the board. And I had that the other day. Now I can go back and rewrite that. The hypotenuse is always equal to a leg times the square root of 2. And you may not be able to see that, but that'll be up on class in the morning. Now the last thing we talked about was we went ahead and said, hey, let me go ahead and let me draw another triangle. I'm going to draw a 45 and a 45, and I'm going to make the hypotenuse 8. Now here's something that should be reasonable, right? In all of the other examples that we did, the hypotenuse ended up being a decimal, and the legs were whole numbers, x and x. Well, in this case, the leg is a whole number, so what do you think the value of the legs are going to be? If you said a decimal, you should be correct. So how could we do this? We could do this 2 ways. We could use Pythag, all right? X squared plus x squared equals 8 squared. But why do we need to do that? If we know that we have xx and x squared of 2, if this is our ratio, our relationships, if 8 is equal to x times the square root of 2, okay, then how do I determine what the hypotenuse is? The hypotenuse is equal to this. So I divide by square root of 2. Okay? And then here, well, wait a second. I can't have a radical in the denominator. So how do I do that? I take 8 square root of 2. I rationalize it by multiplying it by itself. Okay? So this becomes 8 rad 2 over rad 4, which becomes 8 rad 2 over 2. And this simplifies to 4 rad 2. Well, if 8 is equivalent to, well, if 8 is equal to x times the square root of 2, if I know what 8 is, or I know x rad 2, then my leg should be equivalent to, and actually, you know what? To me, I need to think on that a little bit more. That's just a little confusing. Here, watch this. Watch. Much easier. Here is my formula. A hypotenuse is equal to a leg times the square root of 2. I know my leg. My leg is 8. Okay? Excuse me, my hypotenuse. I know my hypotenuse. My hypotenuse is 8. So 8 is equal to the value of my leg times the square root of 2. How do I get the leg by itself? I divide by the square root of 2. So my leg ends up being equal to 4 square root of 2 when I simplify. Gee, this leg's 4 square root of 2. This leg's 4 square root of 2. Oops, that's bad. Go away, 4 square root of 2. My legs end up being decimals. All right, so we'll talk more about that tomorrow and work on that. There's your notes.